All right, here we have lateral surface area, which is just the surface area around the side of it, and the volume of the solid. So the lateral surface area is something that you don't really need to worry about. Lateral surface area is just kind of, let me draw the exact same. This is the suppose this is the same thing as the prism that's shown there. Just get my cursor showing. This is the same prism. Okay, the lateral surface area is just the surface area around that. So we're excluding the bases. The top and the bottom are excluded from that. It's kind of a pointless thing to use, but that's all we're trying to find there. Volume, however, is still the same. So the lateral surface area is going to be this side here, which is 10 by 6. So we have 10 by 6, which is, of course, 60 feet squared. This area here has the same, this measurement is the same as this one here. That means it's going to be an 8. And of course, this distance is the same thing as this distance. So it's going to be 10. So it's going to be an 8 by 10 rectangle, which is 80. And the sides opposite it, right? This side here has the exact same surface area as this back side, and this side here has the same surface area as the back side. So we just need to multiply these by 2 each, 120 and 160. Add them together. That gives us 280. And that's the surface area around the outside. We're not including the top or the bottom. So that should be 280. Now the volume is quite simple for a rectangular prism. It's just all the 3 dimensions multiplied. 10 times 8 times 6. Oops. 10 times 8 times 6 is 80 times 6, which is 420, I believe. 80 times 6, 480. 480. And that's going to be in feet squared. Let's see if this is correct. And it is. All right. Next problem. Same idea, except now we're looking at a triangular prism. So and this time we're looking for total outside surface area. So not the lateral surface area, the actual surface area of this prism. So we have, we do not know the height of these triangles. We need to find the height of the triangles to know the surface area. So let me just draw the prism again. Do dotted lines for the back sides of it. Okay, so we've got 5 sides in total, right? This is 12, this is 12, and this is 22. Okay, for the bases, the triangular bases, we really have a 12 by 12. And, oh, this is actually a right angle. Okay, I messed that up there. This is actually simpler because the base and the height are given. Because of the right angle, which I didn't see that little square right there at the very top of this, that means these are at 90-degree angles. So the base of the triangle is 12 and the height is also 12, or vice versa. That's because the triangle is like this. That's the base, that's the height. That's essentially all we've done there. Okay, so the area of the triangle is 1/2 base times height. 1/2 144, which should be 72. Right, and there's 2 of them, of course. Now we need to look at the dimensions of the rectangles on each of the sides. So we have rectangle 1, rectangle 2 is on this side, and rectangle 3 is on this side. So rectangle 1 has 22 is this length here. We need to figure out what this length is. We don't know what that is. But that's the same thing as using the Pythagorean theorem on this right triangle, right? We're trying to find the hypotenuse. We have 12 squared plus 12 squared equals C, which is the same thing as this measurement here. C squared. 144 plus 144 is 288, and take the square root of that, giving us, so C is approximately equal to 16.97. It says round the integer or decimal round to the nearest tenth is needed. So yeah, let's yeah, that should be fine. Okay, so rectangle 1 has a length of 16.97 and a height of 22. So multiplying those together gives us approximately 373.35. Rectangle 2 is easier. It's a 12 by 22 shape. Gives us 264. And rectangle 3 is also a 12 by 22. That's because they're on the sides that are given, these dimensions that are given here for these two rectangles. And 22 is, of course, the height of all three of those sides. Okay, so the total surface area is going to be the two triangles added up. So we're going to need two of these for the top and bottom sides, and then we're going to add that to these three things. So the surface area is going to equal 72 twice, two of the triangles, plus 373.35 plus 264 and another 264. So 264 plus 373.5 plus, so I'm doing this right here. Yep, and then two of the 72s. I'm getting 1045.35 rounded to the nearest tenth is going to be 1045.4. It's going to be 1045.4. And the volume is the easiest thing to find. The volume is going to be the base, which is the area of the triangle. It's always the area of the base, times the height, which is 22. The base is just the area of the triangle, so it's like this bottom triangle, times how many there are, which is 22 times of them, to fill up this entire volume of that. So 72 times 22 gives us 1584. Let's see if that's right. And it is. Okay, for this third one, we have an upside down triangular pyramid. And what we see here is we have a base of a triangle, and it says assume the base is regular. All that means is that all of the sides of that base triangle are the same length. They're all 2. Of course, they come down and meet at the point there, the apex as it's called. And of course, the altitude is written as 9.4 meters, and the slant height is given to be 9.42, approximately that much. So this total surface area is what we're trying to find, and the volume as well. The volume is easy, right? The volume is just going to be 1/3 the base area times the height. The surface area, just add up all the surface areas. Now, the bottom of the triangle, we do not know the height for it. We need to know what this distance is here to know what to define the area of the bottom triangle. Okay, let me redraw a triangle here as 2, 2, and 2. We need to know what this is here. This is the height. Well, that cuts the bottom part exactly into half, into 1 and 1. And we can ignore this half and look only at this left half, which is a right triangle. This is the height, and using Pythagorean theorem, that's going to be C. We have 1 squared plus h squared equals c squared, or 2. 1 plus h squared equals 4. And h squared, if you subtract the 1 to the other side, we get h squared equals 3, or h equals, take a square root of both sides, the square root of 3, which equals approximately 1.732 and it continues on indefinitely. So that's the height of the base. Now the actual area of that base triangle is going to be 1/2 the bottom side, which is just this, which is 2, times the height, which we found as 1.732. And the 1/2 and 2 cancel, giving us 1.732. It continues on. Okay, so that's the area of the base. Now we need to find the area of these side triangles. And there's 3 of them, and they're all the same. All of these blue parts are the exact same. It's going to be 1/2 area of the side triangles, 1/2 the base, which is again 2, and the height is now the slant height. Slant height is 9.42. The slant height, if you don't recall, is just this distance here, and it makes a right angle with that, with those sides, and it's always the same for all of them. Okay, those cancel again. That gives us just 9.42, which is just unique for this problem, but you just multiply it out on your calculator to find that. Okay, the total surface area then, all right, SA, is going to be the area of the base plus all 3 sides of at 9.42, because there's 3 of these blue sides here. There's this one, and then the back one is also added in there. Okay, doing that gives us 29.99. It continues on, which is rounded to the nearest 10th is 30.0, and surface area is in meters squared. The area, the volume, is 1/3 the base area, which we already found is that 1.732, continuing on, times the height of the overall pyramid, which is the same thing as the altitude, which is 9.4. Okay, doing this and rounding it to the nearest 10th, as it says in the problem there, that gives us, sorry, this isn't 1/2, this is 1/3. 1/3 times the base of the base triangle times the height. Yep, and that gives us 5.4 rounded to the nearest 10th. 5.4. And this is always in cubic units, so meters cubed. We're going to check our answer, and it is all correct.